Okay. Hi, everyone. Welcome to the working group serving meeting. Today is July 10. Thank you all for attending. And before starting, I would like to remind you all that we are bound to the CNCF community rules. So please behave with each other and be nice. So for today, we have Sergey. I see your name as, what happened here? Your name first.
Oh yeah, for work stream updates, we typically do work stream updates in the beginning. There will be some update on OCI image. I mean, I'm talking about DRA work stream. So for DRA work stream and other node related stuff, we have yesterday was a device management group meeting, and we discussed like draft PRs that are already out for DRA changes in 131. And there is some issues that need some attention and volunteers ideally. Besides that, we have propagation of device failures in pod status. This cap is still ongoing. I have some PR out for testing, and then I'm working on actual code change without PR yet. And OCI volume, we will have another topic in the end of agenda. I don't know if any other work streams wants to go ahead and give an update, but there may be not much because last week was very short and many people were off.
Going once, twice.
Just super quickly for auto scaling, I think we'll be discussing some of it a little bit later. I see Justin added some topics there. So that's kind of what derived out of our discussion last week.
Okay. Next is to Clayton.
Thanks. Yeah, so 2 quick notes. One is we had the presentation of the Cloud LLM Gateway, proposal from Dan. I was working on a draft of not an alternative, but a different perspective, which would be around trying to solve the problems in a cube-centric, the operational problems that would be entailed by platform teams running large numbers of use cases multiplexed onto model servers. And I think there's some feature similarities and requirement similarities to Dan's work. I did not complete that document before the meeting, so I will update and send it out via email when I do complete it. But it was, I think there'll be a lot of things that look similar there. And the general feedback that I'd be looking for as well is, I think LoRa is an underserved operational problem, and it's one of the few ways that you can pragmatically share efficiently share use cases across model servers today for large language models, simply because it just doesn't make sense in many cases to run 2 large models on a given accelerator. And so for that reason, there's some very interesting parallels to Cube's early role in running lots and lots of web services across shared CPUs. And some differences too. So hopefully they get that out, and looking forward to feedback on that. Second one was just as a general FYI, part of the working group's goals would be to highlight problems that specifically impact serving, but also more broadly impact workloads. Some of what we've worked on for the last couple of weeks is some feedback around spot instances being inconsistent across cloud environments, but also the recognition that graceful shutdown still has a few areas where we can mitigate the impact and make graceful node shutdown also graceful, even on things like spot instances. And then in discussion with Mernal, I think there's a general recognition that if we don't take into account the behavior of on-premise or bare metal instances that might actually want to not disrupt serving workloads by kicking them off a node, there may be some feature gaps in graceful node shutdown. So the doc is linked. I would welcome feedback, especially for folks who are running on spot instances and maybe running in multi-cloud environments, or people who are running on-premise and have large workloads and use graceful node shutdown. So just a general call out to working group serving, and that's it.
Anyone want to provide feedback on Clayton before we jump into the next one? Looks like not. So, Xiejin?
Okay, okay, sorry. It's my turn now. Okay. Yeah, the next one is I think Ray mentioned gave some updates on the like the auto scaling workstream, right? Last week, last meeting, I think we talked about the like auto scaling. At that time, I think I promised to write a doc on the Kiwi aware auto scaling strategy we used internally in ByteDance, and I think I probably use a different like format in the doc, and also the HPA evaluation methods. I think yeah, since we have enough time, we can briefly talk about the doc. Based on our observation, there's like two kinds of the challenges. The first is the metrics. The second is the scaling efficiency. For the metrics challenge, the first problem is the resource metrics like coming from the DCGM. So those metrics are cannot correctly represent the business of the GPUs. So that's there's no way to solve it. I think that's already I think that's all the definitions can be provided from the GPU now. No matter it's the GPU utilization or SM active or occupancy, we think that's we cannot use those metrics to indicate the business of the servers. The second problem is most of the metrics now, like the latencies or resource metrics, they are not linear, but the HPA algorithm, they are definitely linear approach. So that means if you like to use it, if you like to use HPA, the metric has to be linear as well. So I give one example we observed is the latency spikes, I think almost 4 times like P99. But the symptom is it just start to queuing the request. So it just need one more additional like server to handle that traffic. So if we think that's linear, then it takes 4 times of the pause. But in fact, it just need one more server. So that's about the linearity of the metrics. The third challenge is the traditional metrics like QPS or concurrency, for example, like those metrics adopted in Knative, that won't work anymore in LLM cases. That's the LLM specialty, because the prompt size may change, and due to its regressive decoding feature, the output cannot be predicted as well. So we see a lot of like production metrics, like the QPS are exact the same, but the SM spike a lot due to the length of the request. So the second efficiency challenge is the metrics collection chain is pretty long. I have a figure below. If we use like GPU metrics, that's a pretty long journey to come into the HPA. Like the DCGM exporter have an interval, and the Prometheus have an interval, and the adapter add another like interval. Eventually, when we come to like HPA, the decision loop, there's another like sync period, right? And the yellow highlighted are user specified, like the stabilization window, and the pink one, actually the pod takes long time to scale up. That could be solved by model acceleration separately, but the overall chain is pretty long. So that's the efficiency challenge. This is kind of critical in LLM area. So we proposed like few things to address the relieve the problem. The first one is the KV cache, KV aware auto scaling. Could you scroll down a little bit? So the first challenge, I think we talked about the linear metrics. Those metrics cannot be used. So we do some white box optimizations. We think, okay, use the KV cache to do the auto scaling are the best solutions so far. If we can detect those model details, because request may vary, but if we check the utilizations for one request, we can calculate. We cannot exactly calculate how much KV size it used, but we have a rough range, because the minimum KV cache used is the size of the prompt and the corresponding KV size. And every model have the maximum token length, right? That could be the upper bound. So with this range, we know exactly KV cache range is used, and with all the requests, we know exact KV cache they used. And for one inference engine, besides the model weights, and some of other processed use the GPU memory, all the rest will be KV cache. And in that way, I think we can easily know, okay, for one GPU, how much KV cache is left. So with the demand and the supply, we know how many GPU servers we need. So that's our, I think, proposed idea. I know this is probably not that straightforward, because we use a lot of formulas to do some calculations. But in practice, if you like to use this way, in a very straightforward way, you can use a KV cache utilization percentage in some of the engines. For example, like VLM support the percentage. I think some of others support as well. But the percentage solution have some drawbacks, because the cache can only change from 0 to 100, right? 100%. So the scaling will occur in stacked increments. If we have a lot of requests, it won't scale to the target numbers correctly. Yeah, so that's a different way we measure the LLM metrics and do the auto scaling. The second approach is the proactive way. So in the past, we do a lot of time series predictions to predict the traffic of the server. But the problem is it doesn't work for LLM scenarios based on the because of the technical challenge 3 we talk about, right? But with the first KV cache estimation, these two approach works perfectly. So that means the reactive the cons of the reactive scaling in the first solution can be addressed by the second two. So these two techniques combined together works for our case. And the third proposal is the faster metrics collection path. I think we haven't finished this yet. It's still pending experiment. We like to skip the Prometheus and use the autoscaler, use a separate autoscaler to manage the problem metrics directly to handle some spike scenarios. Right. Okay. And the second part is the evaluation indicators. So I think in the past, the one big challenge is when we change the auto-scaling algorithms or change the settings, like those behaviors from HPA v2, we don't know how to evaluate it. So we list a few key metrics to do the evaluation. First is the provision timeshare. The second is oscillations. The third is SLO violation, and last one is resource usage. I think from the name wide is pretty easy to understand. So I list some examples below. the first diagram, it just shows the pod changes and like the time provision time of the like pod demand and the pod supply, and we can see some of the like the areas are not. I mean, the yellow line covered areas are underutilized, right? Because the demand already go up, which means the HPA start to work, but it takes some time to provision the resources, right? The yellow line covered areas, which is the small areas, means it's over provisioned. So that means it's start to scale in, but we still have the pod. So normally in Kubernetes system, this is not happening frequently because the killing pod is very fast comparing to bring up a pod. And the green line covered area of the resource usage like areas. So in this diagram, we can easily calculate the oscillations provision time share for like underutilized, under provision like time. And resource usage is the overall areas it covers for this service. We use these three to we can read those signals from this figure. And the second one is the SLA violations. So actually, we can easily have a SLA line and calculate how much requests are over the limit, and it's easy to know, okay, how much requests are over the SLA violations or how many errors. So we use these two together to represent the SLA violations. Yeah, so that's like a short introduction on the solution, the methodologies we used for LM like auto-scaling and the evaluation methodologies. And feel free to leave some comments. So some of I think the code are not open source yet, but we're trying to spend some like time polishing it and probably publish it in a more cloud native way, because right now I think it's not in fully like a cloud native fashion. We like to collect some feedbacks. Yeah.
Thank you for the detailed document. Questions, anyone?
So one question. So for Justin, thanks for this. So for the first one, that when you are calculating the KV size here, so are you considering the maximum the context size? So how did you calculate for the whole system here, the overall system load?
Yeah, so because this is per this needs to be calculated per model. So in practice, we configure so every service we can think service to model is one-to-one mapping. So if we consider the overall system, yeah, we need to calculate the like different models. But every model have their own like HPA policy. Right, and the overall for single service, actually the overall load is determined by the total request. Yeah, so that's our like assumption in our settings. Yeah.
So in that, if the requests have varying token length, so how does it actually work in this?
Oh yeah, that's a good question. I think that's something we cannot do like 100% as like precise estimation. So there will be like a range. So current our solution is do some like statics. So the lower bound is the prompt size, right? That part I think based when if we do reactive way, the request that comes in, we know it before it generate it start to decode the tokens. We know that. So that's the that's easy to get, and the maximum number is the max token loss. That one we know it as well. So based on the observations, like what's the P50, like when P50 input token length and output token length, we all know that. So based on these like metrics, we finalize the formula. Yeah, does it make sense?
Yeah, so
it does have come with yeah.
Got it. So
It does
to be estimated on the observed values that you are receiving. Got it.
Right, yes.
Anyone else got a question? Or if not, we can move to the next one, which I think will be the same person. Is this related or a different topic? Shannon?
Yeah, it's a different topic. We try to see any one have the distributed cache like requirements, because we think this is super important for LLM serving. So current we do see a few use cases. The first one is the KV expansion, because now like a lot of like prefixed prompt can be reused, and that will be a like very critical components to inference like system. But that's definitely some solution can be done outside inference engine as a separate components at the infrastructure layer. And the second use case is the preview disaggregation, because right now the implementation wise, there's a lot of like challenges to make it make two like preview and decoding pools. So with the KV cache, so they can like store their intermediate like result in the cache pool, which makes the implementation simpler. And yeah, just like to collect some like feedbacks on this, and we probably can have a discussion later, or we can post some like RFCs or proposals later for more discussion. Yeah.
We're good on time. Anyone want to comment on the distributed cache for KB, or we can move forward for Peter topic?
I want to ask from some clarification here. So are we thinking about a faster way to transfer KV cache between host to host, or having some sort of automated way to replicate between hosts? Like what's the idea here?
Yeah, so the idea here is to do the disaggregation. We since a lot of like prompt calculation can be saved, so we like to disaggregate that part from the inference engine to a DRAM, CPU DRAM pool. So so people can or different engine instance can reuse the like those prompts. So yeah, that's the purpose. And the communication efficiency is a separate problem. Like how can we accelerate the KV transfer? Yeah, that would be a separate topic. Yeah.
So for this one, are you thinking of having multiple hosts to do the disaggregated serving, or a single host between different accelerators for this aggregation?
That's for like that's for multi-host. I would say that's for multi-host. So no matter there's the intra request or inter request, I do think they have some like scenarios. Like for prompt reuse, that would be cross request. For disaggregation story, sorry, for the prefill and decode compute disaggregation story, that would be like a single request. So yeah, that's the case. That's I think the heterogeneous won't be related. Yeah.
Okay. So just to summarize, so you're talking about single host sharing this cache on the host DM, right? DRAM.
It could be multiple hosts. It depends on the load balancing strategy, right? If we have two engines on two different servers, they can definitely share one like prompt prefix
Sure.
the prompt. Yeah.
Okay.
Okay, thank you. Peter?
Hey, all. I mostly just wanted to ask for reviews on the API PR. And it does look like Clayton has already taken a look at it. But anyone else who has any input, happily accept that. We're looking to shore up the implementation here for OCI volume sources. So if you could take a look, appreciate it.
And I was going to add, I think it would be good to have like a naming discussion, but we can do all of that in the PR. Is there, do you plan on discussing this in SIG node, Peter, or in the next SIG node meeting?
We can do it in SIG node. We can do it whenever, really. Sasha, as being the main author, works in Europe time, so like SIG node doesn't usually work for him, but I can always relay information to him if we need to.
That's okay. I think we can just do all the discussion in the CAP. I don't think, or in the PR. I don't think there's a reason to have to go to a meeting. I just didn't know if there was one. Okay.
Cool. Yeah. Thank you.
Okay, any more topics? If not, we will have run short on half an hour. Going once. Going twice. Okay, if not, this is it for today. Thank you all for attending and see you all on the next call.
Thank you. Bye.
Thank you.